Okay. Any other questions on the paging system?
Now, in terms of offices, nothing in the office, private offices, right?
Private offices, you're going to come through your speakers on your phone. More than likely, they have a telephone interface into. They have a telephone interface into the paging system, so they can just dial directly through there. They can do an on-call on telephones.
If there's any question about the location, anybody knows working with them? I told them based on what you guys told me years ago is at minimum of two in every common area. And then after that, 30 on center, like you said. So still valid. Just verifying that.
Okay. There's no questions on that. Let's move on to the clock system. These are pretty simple now. They used to be a pain in the rear because you have to have a conduit system wiring them all up together to synchronize them. Now it's just you put in one module. Usually it's going to be in the electrical room, the telephone room. It's going to run an antenna up to the ceiling, up to the roof. And then throughout there, everything is going to be wireless. The only thing the owner has to worry about is batteries. They got to replace them usually every 2 years. When you're going out in this area, they code for 15-inch clocks. And the main thing there is, there's no code requirements for where you got to put clocks. So I would just put them usually in the common areas where people are mostly travel, and probably one on each side. Wall mount. In the manufacturing area, because it's just going to be looking just like that. You just put it up somewhere where they can see above the equipment. Most of the time, and like I said, it's just plug and play. You go out there, drill it, hang it, put a battery in, it automatically synchronizes. In the office areas, it all depends on what the owner wants. Most of this is going to be a conversation with the owner saying, what are they looking for? Because everybody in the office is going to have a clock on their laptop, on their computer, on their phones. So everywhere in the office area, you're pretty much going to be able to see your clock. And I don't know what you guys, but I don't look for a clock anymore. I just pull out my cell phone. If they're tying into a punch-in, punch-out system, there's those interfaces as well, depending on what the owner has equipment provided. Usually that's right by the owner, and you just tie it in. It's a module, synchronizes with it so that they can just, when they punch in, punch out. Clock systems, yeah, they've become real easy now. Everything is wireless.
So everybody got that you have to have a master clock, right? Like you said, one master clock driving all these units.
Yeah, so it's not a master clock, it's just a master head-end system. It's going to be in here with an antenna going up to the roof, and that's
So
good.
what do you call it? Master control or something?
Master control. Yeah.
So make sure you drop that one, guys. So if you use the Firemount panel or any of these low voltage panels, rename them in Revit, and they'll get you there. Because we're using Revit, trying to think of the panels to find. Do Shelby, keeps popping up.
There is no. It's kind of basically making a walkthrough of the area. Where are people going to be in the manufacturing area? They're going to be usually in between, walking in between. So I have one up here, one over here. Sorry. So, yeah, that's typically where people are going to be looking at. If there are people at certain controllers, if they want one above a column in the control area.
Like this here.
Yeah, just like 4 of them in there. Put them. I mean, there is no height requirement. Yeah, offset them. Yep. And once people know where they are, they'll know where to look. But like them now because it's just plug and play. They have their own mechanic, or maintenance staff. Just walk around, replace the batteries every 2 years. So. Any other questions on that?
Yeah, before you leave, just to remind you that this is manufacturing floor, so they might have a specified time where they have their breaks. So wherever you have people who are working on these machines, they will be able to see the time for the breaks and the buzzers, and they'll be part of the.
And that can all be tied through the paging system.
Paging system, yeah.
With the controller.
Okay.
So it's all based on schedule now. It's all like a laptop set of schedule.
That'll be part of your paging system.
Yeah.
Okay.
It's tie in to a module, whether it puts a tone out there or for the most part, back when I used to work in manufacturing, before I came to Dunwoody, it was, we had clocks, but they've kind of gone away now. They never really looked at them. It was punch in, punch out. That's when you knew you had, and when you had time, you went. So.
We do also have a second floor.
Second floor up in this lab area.
This will be the 3 air handling units here. And this is the NAM, with a clean room here. And we have a lunch area here, a break area, with a couple of offices in this area.
Break room, you usually have one mounted somewhere centrally. Depends upon where people are sitting for the most part. Usually they'll have TVs or something in here, but yeah, towards the entrance. And on the wall they'll see it in the conference room. You can't put one in there. Typically you're not gonna, a lot of conference rooms now that you go into, you're not gonna see an actual clock in there. Most of the time, again, it's just on the phone. People need to look. They look at the phone. Lab area, you can put one on each side. And the clean room is raised floor.
It's a prefabricated clean room.
Okay.
So it's a big box.
Usually in areas like this, you're going to have a digital clock, digital sign with the red scrolling. They usually put one up on top, but they don't want, there's limited space in there on the walls, everything with all the tools and everything in there. So it's just these 2 bays. The other ones are
Benches. So work for you.
you know, one down here, one up here. Should have it covered. Any other questions on the clocks? Now let's get into the fire alarm system. This is what I specialize in at OVC. I know all the systems. I know enough to be dangerous in all the systems, but I prefer fire. It's a lot more fun with this. The thing with fire alarm that's a challenge is when you're doing fire alarm security, you have to have a lot of interaction with the customer and the owner to figure out what they want for the security system. When it comes to fire alarm systems, there's a lot of codes that you have. Right. But if you're talking about fire alarm, there's a lot of codes you got to look at. At LBC, we try to be the experts on fire alarm systems. So the codes I need to know are the National Electrical Code. I need to know NFPA 72. I need to know the mechanical code. I need to know the sprinkler code. I need to know the elevator code. I need to know they have special NFPAs for clean rooms, data rooms. They have special for hazardous material areas. There's a lot of codes that you have to know, but once you get to know, once you know them, they'll change on you. It's great. Minnesota just adopted NFPA 2010, which completely changed it. It's no longer the fire alarm code, it's the fire alarm handbook and signaling, or fire alarm and signaling handbook, NFPA 72. And what the fire alarm handbook tells you is the code tells you where you have to put the system in. NFPA 72 tells you how you have to put it in, how you have to install it, how it has to be certified, how it has to be tested. The Minnesota State Fire Code, Minnesota State Fire Alarm Code is a book about this big with just a bunch of different amendments. Mostly you're going to be looking at section 907. That tells you about how to, or where a fire alarm system is going to be required in the building. In this, if there was no clean room system in here, if this building was fully sprinkled, it would be B occupancy, fully sprinkled. No fire alarm system would be required other than monitoring of the sprinkler system, control of the elevators for recall, and monitoring and control of the air handling units to shut them down. So it used to be that the air duct detectors in the air handling units were an alarm condition. That's changed now. They are all supervisory alarms, so it's not going to be sent off-site through monitoring stations. So we'll jump over to the plans and we'll start taking a look. Typically when I'm designing a fire alarm system, the first thing I like to know is where the mechanical contractor or plumbing contractor is going to put the riser for the sprinkler. And the mechanical electrical area. Yeah. I think this is mainly going to be chillers, boilers. So I imagine up here is your OSMY valve and your sprinkler system are going to be coming in through somewhere in this back corner area. Depends on where the fire department has access to the OSMY valve. Fire alarm panel is most likely going to go in the electrical room, or telephone room, or within the electrical generator room, somewhere close to the telephone lines for the dialer. Depending on the size of the system, there are different size of the building and number of devices required. There are different sizes of panels that you can get. You got panels that'll handle 100 points, panels that'll handle 320 points, all the way up to panels that'll handle 2,000 points and can be networked up to 20,000 points. So it's all dependent on what the code is going to require and how many devices are you allowed. Typically, in the specifications, the engineers will tell you you can only put 80% of detect devices on a single loop. So it's designed that way, but in fire alarm system, the new ones that are coming out, it's all computer based now. You're not looking at hard chips, you're not looking at burn-in boards, so you can easily upgrade the fire alarm system. So we're going to be monitoring the 4 sprinkler zones. So up in this area, you you have 4 sprinkler zones. You're gonna have your main flow and your main tamper, and you're gonna have usually a flow per zone. So you're gonna be looking at what they have is 4. You put 4 dual monitor modules up in this area. Yeah, typically when they're doing the risers, they're gonna use dual monitor modules. It's just 2 modules in one box, so you don't have to have all separate.
That would be the Fender switch and full switch, and for each one. Is that what you mean? Okay. Like we did in the commercial guys, one zone is gonna have tamper, every zone is gonna have a tamper and a full switch. We'll have 4 zones for a total of 8 devices. Tamper for flow, right?
Yep, you got the manufacturing first floor, computer room pre-action, the balance of the first floor and the second floor. They've gone away from it in code, but they brought it back in the NFPA 2010, is that at every panel, power supply that you're putting into the fire alarm system, you must have a smoke detector above it. So in your electrical, if this is where your fire alarm control panel is, that you're going to have a smoke detector and a manual pull station next to it.
Matt, is it okay to put in a telephone?
Yeah.
Low fuels? Doesn't have to be in the electrical.
No.
They probably right now the low voltage we're gonna put them all here and leave this one for our electrical equipment. There's no.
You have to have a dedicated
Yeah.
breaker for them.
So you need a smoke detector right there.
Yep, this is right above the panel, and the ceiling above the panel.
And the pull station?
And a pull station. Since we were talking about those air handling units earlier as well,
Should we look at that one?
and the second floor, fun little fact is on the fire alarm code, duct smoke detectors are required on any air handling unit above 2,000 CFM. The fire alarm code requires for them to be on the return side. The mechanical code requires them to be on the supply side. So depending on which authority you're working with, is what they're gonna argue about. But typically, it used to be you had them on both supply and return. Now you just do it at supply side, have them on the return.
So, for the return only?
Just the return only, yep.
How many did you say the H units?
2,000 CFM. Anything above 2,000 CFM. So roughly, what is that conversion? 1 ton equals 500 CFM. So anything above 5 tons is going to require a duct smoke detector. And again, with each duct smoke detector, you're also going to have
You think right there. No, that's fine.
each duct smoke detector.
It's there.
Yeah. Here's your duct smoke detector. With each duct smoke detector, you're going to have a control module, a relay module, and more than likely you're going to have a remote test switch. You got a control module, relay module, and then a remote test switch. If the air handling unit is up above, hard to reach, the remote test switch can be located down somewhere accessible. Engineers and building maintenance, they love that because they come up and they go, they can see that the system's working when we go do our test. When we're going to do our inspection, we just go up there with a key. Yeah, work shut down. Okay, put it back on.
circular.
Just for my reference, or my point of view, we were using CAD, AutoCAD, Autodesk when we went to school here. It's good to know, because if they have questions, if our CAD guy is out, they'll come to me. But for the most part, when it comes to fire alarm systems, all the designs are going to be freehand. We prefer it that way just so we can manipulate it. Could get into CAD, but I prefer, again, I like to have a piece of paper in front of me so I can look at the whole big picture and zoom it in as far as I want when I plot the plans. Like I can break it off and have this area all one. Just do my design just like that instead of having scroll in, scroll out, because I always kind of. Okay, that was the duct smoke detectors. That's required. The other thing that's required for this building is over here on the elevator. You're going to have elevator recall. With each elevator, there's going to be 4 control modules. You're going to have primary, secondary, shunt trip, and firefighter's hat that you have to control. And that's usually going to be in the elevator first floor. Yeah. Elevator bump from here. This is where you're going to have your 4 control modules. You're going to have a smoke detector located in the elevator control room. You're also going to have a smoke detector located out in front of the elevator lobby, out in front of the doors. They have to be within twice the area of the opening. So, twice the area of the doors. So you have to go up to 8 feet, depending on some of the doors. Not unless they have it sprinkled, and they're going quick. The code says they do not want any sprinklers in the elevator shafts or even in the elevator room. Otherwise, you have to have a heat detector in there, shunt trip all the equipment before the sprinkler goes off, and have a high temperature sprinkler in there, and a heat detector that's rated for 15 degrees below that sprinkler. They got away with all that, thankfully.
You need a heat detector here.
No, only if it's sprinkled. If there's sprinklers in the elevator shaft, then you have to have one in there. But typically, nowadays, they do not, the code does not require them, and then fire marshals and the elevator contractors or elevator inspectors don't want to see those.
One in the room.
You're going to have 1 smoke detector in here. Yep.
So one here, one here.
Yep, and then 1 up on the second floor.
One in the second.
Same spot as this one. And that's going to control your firefighter hat, your primary and your secondary recall. With that, based on if this was just a occupancy fully sprinkled, that would be your fire alarm system. But now we're going to talk about the clean room officer. Actually, get into notification real quick. The occupancy fully sprinkled, the code says you do not have to have any notification in the building. However, the owner may come back to you and say our insurance company is requiring us to put notification throughout the entire facility. That's where a lot of this will come in. In corridors, notification devices says you have to have a horn strobe within 15 feet of each exit. And horn strobes can be 100 feet in between the next device. On a corridor that's less than 15 feet wide. In a corridor, if it's less than 15 feet wide, you can go 100 feet between devices. stairwell is not, no, that's not part of the exit to the corridor, that's more
50 between, right?
100 feet.
100 feet, right?
Yeah.
These are your points, right?
Mark strokes, yep.
I know. But you got that one guy expecting from the exit, 100. We don't have 100 feet, always anyway. But
Don't have 100 feet, that's right. In your open office area. From every exit into out of the corridor. So the stairwell doesn't make that entrance into. So like you have one.
how about the second floor here? Here's the second floor, that's what we're confusing. We have a hallway that's coming right here, in the half of the room that's this hallway.
Okay, on the second floor, this would be an exit, yes. So you have to have one within 15 feet and one within 15 feet.
So probably in the
And then
100
100
feet.
feet.
That's good.
First floor in the office area, you're gonna space your orange strobes every 50 feet on the center. So you just pick a corner, 25, 25 for your first one, you're gonna be 50 feet. Ceiling mount, yep. It's just right, device, typically like this, except for that's a wall mount device, but
Are you considering now, like, that's an open office space, you're considering?
I
that
consider,
corridor?
yeah, this open office.
Okay.
But a corridor, as long as if it's more than 15 feet wide, then it's considered open office, and you gotta go by 50-foot standards.
Well, even if like that one is just cubicles, though, right?
Yep. It's just
Which one?
cubicles.
Yep.
So same thing in the lobby here.
So you're gonna have one within 15 feet of that doorway. One side.
Typically, but if you're
Good,
gonna
you good?
I'm just trying to see what the distance is here, the dimensions are.
And where is the, before you, oh, it's up to you.
Yeah, right there, 37 feet.
37 feet.
So you should be able to cover.
19 by 37.
Okay.
That's
You'll
one.
be able to cover it with one in the central area. The way I look at it is if it's 50 feet in between, then I'll just put one on each side. That'll cover you. At 50 feet, because it's 50 foot is your coverage, 50 by 50. So you're covered in here, you got your office area covered. Let's go into the manufacturing area. This you're gonna set up just the same way as basically the paging speakers. Except for, you can do column mounted out here, if you have them, if not, just, you're gonna do around the walls. And again, it's gonna be every 50 feet. Depending on the noise level, you may want to just offset every other one as a strobe, so that the visual indication is more of what they're looking for, and they'll know what to look at for the fire alarm system. The horns are just noise, pretty much in the manufacturing area. And once again, in this area, we have class 1, hazardous area, class 1, div 1. You got the beacon strobe, which is usually typically yellow, and the horn, which is the class last one and one more. You're gonna have a horn strobe in the mechanical room. They might have one on each side, depending on how much equipment's in here. So that anybody who's working in here, can see, they'll be able to see one side either the flashing, because they're probably not gonna be able to hear in there, but they like to be able to see some kind of visual indication that something's going on. If you got one of your maintenance guys working on a chiller unit in there, then you can be able to see something.
It should be.
Shipping area. Wall mount units here. I will put 2 in this area. You got same thing mounted 80 to 96 inches. Typically they're going to be in conduit out here. They don't have to be weatherproof since they're assuming it's an enclosed dock. That pretty much covers the generator room. Yep. You're gonna have 2 in the generator room. And areas like this that are usually they're gonna be high bays. Is this going straight up all the way to the second area? Rooftop units are on top of it? They're on here. So this depends on the height of it,
I
but
think it's 18 feet,
18 feet.
but it has its own height.
Okay. So again, usually you're gonna put them on the interior walls here, because it's just easier to fish over to the power supply that's gonna be running these. Each power supply has 4 zones on it typically that you're gonna use to run. There's all calculations that you gotta do when you're submitting to the authorities, the fire marshals, for your permits. You have to do a calculations on your amperage, your power draw, your battery life, your battery draw on the devices. And then when you go to do your test, all these devices have to go for, take the power off for 24 hours, and then they have to run for 5 minutes straight. If they're asking for more codes, you have to size your batteries properly, because some of them will say go 24 hours without power and then run for 15 minutes straight. And the fire marshal will make you do that on one of them. Typically, if you have a good relationship with the fire marshal, they know you did the system correctly, they're not going to make you take the system off, because they will sit there and do that. They come home, they will turn the breaker off on the fire alarm system, and they will lock it, and they will say, okay, we'll see you tomorrow. And we meet at the same time, and they come out, and they go, all right, run it. But they can, if it goes 4 minutes and 58 seconds, you fail. I'm sorry, which, the power supplies? Oh, usually we're using 7-amp-hour batteries in the panel. We have 2 7-amp-hours typically. That's just drawing, that's just for the powers. Excuse me, just for the panel. The power supply has its own battery backup as well. That'll run the horns and strobes. So. Depends on the size and number of devices and the draw that you're coming up with. How many devices you have. Any other questions on that? Sure, I'm throwing a lot in. Let's talk about the computer room. We have a pre-action system, which is just a dry pipe system. So you're going to monitor, you're going to put a pre-action panel in there that's going to be able to monitor. Let's see here. This raised floor?
Yep.
Drop ceiling?
Yep.
Okay. On a raised floor, the code requires that depending on the number of of exchanges for the air is how you're going to reduce your smoke detector size spacing. Starting at 30 feet on center, 900 square feet, and depending on the amount of air exchanges, it can go down all the way to 9 feet on center. And this system in here, you're going to use smoke detectors, but typically people are using now is Bethesda. It's just an air sampling system. So you're going to have one panel in this area. You probably have two panels. They have a 4-pipe system that you're going to want to look at 4 zones. And you put one panel here. What you got to do is you got to cross zone them as well. See if I can do
You can grab, zoom in. Let's go for, highlights. Sorry. What do you zoom?
just there you go. That'll work. Typically, when we're designing a computer room or a clean room like this, we're going to use a Bethesda air sampling system, and that's a pipe system. And all it does is run a pipe down underneath the floor, and it's got air sampling pipes in it that are currently drawing air. So, but you're using the same spacing on your sampling pipes that you are as a smoke detector, depending on the air exchange. So, we have that information. So we're going to assume that it's 9 feet. 9 feet on center. So you're going to start out here with your Bethesda panel. Your first pipe is going to come down and come over. You can T-tap off the pipe. No, this is going to be underfloor.
Can I just inject one with body? I don't think they're familiar with. When you guys have a data center computer room, there are 2 types of smoke detectors that you're supposed to have. One type will be in the ceiling, and the other type is under the racing. So the one on the ceiling, I don't know if we're going to talk about that one, if it's required or not. But he's talking about right now is when they raise the floor and they put all these racks full of computers, and underneath it they put smoke detectors or that Vespa system, which is set with pipes, plastic pipes that with a compressor, right? And it samples the air. It's sampling the air and it's smoke detector. So there are 2 systems. Be aware that one thing is smoke system underneath that. Yeah, it will be.
Yeah, usually they have a couple of crack units that forcing the air through there. What requires you to have the protection underneath is all the cables and any combustible material. Yeah, you got your crack
Yeah,
units.
crack unit 1 and crack unit 2.
No, what it was, it's probably a floor like this, but then it is raised up, usually 18 inches. So there's a space in between there. And that's where these detectors are going to go. The air is going through there.
What these squares, guys, these are racks full of computers. Each one of these squares, imagine a rack, say 7 feet high rack full of computers, servers. Remember how Michelle Cooley came and you see the PDU's power distribution unit. Each one of these squares will be filled from one PDU and the other PDU. 2 feeders coming to them. So there's a lot of wires right underneath this first one, tons of wires. The smoke detector underneath there, if there's a fire, right underneath, we put all these wires on power system. We need to be able to recognize it and act on it. Am I right here, man? So that's kind of the whole idea. It's a special room. It goes raised floor first, and there's computer equipment. And they have their own cooling units. This is computer CR, the crack unit we call them. See, this is computer room cooling units. Very specialized in just pushing cold air right underneath the raised floor to keep the servers cool so they can crunch more numbers. Otherwise, the servers will not function right. They will heat up and fail. So they have a special cooling system just for that particular room. One of the, I'm sorry, I'm injecting. There is an Allianz, we're going to go to Allianz right here, 394, and we're going to
it's 2x2 lay-ins, tiles. Yeah, basically, I guess put 2x2. It's a pain to. It's a challenge when you're trying to get in there. Usually, when we're doing our inspection during service work under there, unfortunately, at our work, it's the smallest guy who gets called to do it. Yeah. Don't worry about it. So, okay, we got our first pipe coming down. This is going to be tied in. Since this is a reaction system, all these systems are going to be cross-zoned. Alright, you got your controller, your first pipe coming down. Going over the sampling pipes are going to be, our tubes are going to be roughly every 9 feet. All the way across. Your second pipe, which is a separate zone on the system, is going to be 9 feet away. And you're going to have the sampling of the same pipe. Depending on this area, how far it is, so we're at 40 feet.
Yep.
So we might be looking at a third or a second system in this area. These systems, these two pipes are going to be cross-zoned, so that if one zone goes off, it's not going to do anything with the pre-action system. It takes both the systems to go before any of the pre-action system will go. Typically in this area, you're going to have an emergency power-off system, so that when the pre-action system does go into alarm, EPO goes on, shuts everything down, then the water will flood into the system. If you don't want to get any of this wet while it's energized. The VESDA that you have underneath floor, for the pre-action system, yeah, it's going to be in the ceiling mount. It's going to spray everything. Unless they do like a clean agent system, but I think it calls out for, yeah, it's just a pre-action sprinkler system. Have you guys had a sprinkler contractor in here? No. Okay, the sprinkler, the pre-action system, it's typical of Minnesota in garages and everything. What it is the pipes, it's a regular sprinkler system, but the pipes are filled up with air and there's a locking valve. So that if the smoke or the sprinkler, don't have any, if the sprinkler head were to go off, right now it'd be shooting out nothing but air first, because all that air's got to go out. When you do have a pre-action system, and I forgot to mention this, the pre-action system, you're going to monitor the flow, or the from the pre-action panel, you're going to monitor the alarm, trouble, and supervisory, high air, and low air. So you're going to have 5 points that you're going to monitor from this panel. Because you got to have, since there's an air pump compressor, usually wherever this pre-action panel system is located, they're going to have an air pump there that's always keeping the system filled with air. If it drops down too low, water will flood into it. If the pressure gets too high, it'll plus the head. But typically the valve there will keep it from closing, keep water from flowing. Even if you were in there and knocked off the sprinkler head, it's not going to go until one of these other smoke detectors or other systems go into alarm and release that valve. That just confused that for everybody?
what they're trying to avoid is you have millions of dollars of servers crunching the transaction for own people. You really want to go somebody sleeping in the room and not take one of these sprinkler and give him a shower? That's what they're trying to avoid here, by having this air. So if you accidentally knock it, you just come air out of it, then somebody else will go there, and no water is going to come and bring the equipment. Okay.
We have a large system at Thompson that they tell us if something were to happen and that system goes down, if their UPS gets wet, it's costing them $5 million a minute. That's how much information and everything, trafficking goes through there. If it's energized, because they use charged water usually, or ionized. I'm not exactly sure what they do with the water, but if the system is de-energized, it's not going to damage anything. They just, yep. Once everything's shut, they'll just power it up and it should be good to go. The VESDA system that you have designed in here with the cross zoning, you're going to mirror that up in the ceiling, because you're going to have the same amount of air exchange.
So Matt, we do have a little problem here. We do not have families for Vesta. Everybody understand that? We don't have a family right now for Vesta and Weather. So, so either the other option is to do exactly the same thing with two sets of smoke detectors, right?
Yeah.
One set at the top, let me see, and one set at the bottom. So, I'm looking at you, wondering where's that Vesta?
We can go with a smoke detector. So the smoke detectors, you're going to have your system come in here. You're going to be first one 9 feet, so you're going to 4.5 by 4.5. There's going to be your first. Again, another 9 feet. These are your smoke detectors going all the way across. Coming up.
What you're doing, you're gridding him at 9 feet,
Yeah, 9 feet on center.
and half of it from the wall. Makes sense? Like we did with lights and that's all.
This should give you a good idea.
So there'll be a lot of smoke detectors, and these are the underground, right? The underfloor. But we have done it.
It's going to be tied into the reaction.
We talk about Revit, but we have done it in the past. But we use the same smoke detector, and you're stable underground.
So when we're talking about cross zoning, you got all your smoke detectors in the area 9 feet on center. When you're cross zoning them, the circuits are going to look like this. Next one. That's going back to your panel. And the way it is any one of these smoke detectors go off, it's not going to do anything. It has to take both. You have to have it on 2 different lines. As soon as those go off, then the reaction system will release, water will flow into the system. System charge will start the heads go off. We'll turn off that EPO system. No, these are just photoelectric smoke detectors. Ionization detectors are pretty much going away. You don't see them anymore. They're pretty much stopped producing them. The photoelectric smoke detectors are where you're going. Not getting into it too much, but what you're going to see a lot now is the advancing of technology. They're coming out with video smoke detection. So you can use a camera and it can pick up a smoke detector. It can pick up smoke. Let's say up to faster than a smoke detector can.
Is it approved by the?
By 3UL right now. So it'll be a few years, but. And then this will be, again, mirrored up on the ceiling. The other way to do that is label an A and B. Different circuits.
But we do the same layout in the city, so we don't go higher on that, like.
Depends on the air exchange. It's usually what you got down here, mirrored up on the same air exchange, so.
Is there any limitation on how many detectors you can have on this?
Depends on how big of a system. Like the NFS 640, you can have up to 159 detectors on one. And if you need more, you just throw in another loop for it. But then also you factor in the 8% of the circuit, so you're about 130.
Remember, it's really not a whole issue. This is a personal system.
Yeah, it's all addressable. Each point.
You're taking two wire signals and you're just taking these, like your laptop, you have an address for it. Any question is about the computer room? Everybody got that we're going to go under the floor and in the ceiling. The most important thing is that they are 4.5 from the walls, 9 in between. Under the floors and in the ceiling. Cool, everybody got that one? Please write it down because I don't think we have it on our smoke detector.
And I can talk to Guy too about getting that. Sure.
Second floor. Oh, yeah, there's one thing. I guess there's the manufacturing area we specified what do you call these beam smoke
Oh,
detectors.
yes.
Beam detectors, you know. Just a few things about that.
Beam detectors are pretty much exactly what they sound like. You got a transmitter on one side, a reflector on the other side. And just as the beam goes out, it creates a space 35 degrees on either side where you're looking at. So you're not going to get, it covers the majority of the area. There's a lot of big spaces like this. There's going to be a lot of air movement through there. You're just trying to cover as much of the area as you can. Yep, you just have, like, you got one here and one reflector, so it's going to go out 35 degrees, and so you wouldn't cover the whole area. So you're going to have another one probably up here, and maybe one over here covering a small area. That's the conventional way of doing it.
This will this is what
This is your beam.
yeah, my beam is okay, we put them in the corner. I told them one time we can do like a connect process this way. That's kind of probably
Yeah, typically what you're looking at is you're looking at a maximum of about 200 feet. You don't want to be going in between a lot of beams. You want to have clear line of sight as much as you can. With beam detectors, there are a lot of things that affect them. Dust, if there are skylights, air, skylights, as the sun comes through, different reflections can also give set off some particles in the air, But if you're hitting beams, if it's reflecting off beams, you get different, because all this is a beam, and it's just particles that are up there. So once the smoke comes out, it just breaks the beam. Yep.
what's the height that we placed in
The height below the ceiling, anywhere you can get a clear line of sight. If it's straight up to the deck, huh? Yeah, exactly. If you skim above the area, you're not gonna have stratification, you're not gonna have to worry about that in this area, because, I mean, the smoke has to get up to that area, it's gonna be above the sheet. It's not gonna stratify. Not typically. They can. In an area like this, if they were really worried about it, I'd recommend the Vesta system. Just because it's air sampling, it's a pipe, and it's easier to test, you're not gonna damage it. If they do have the trolley and everything going across here, cranes, whatever, it can always put these into alarm or put them into trouble. You know, if they don't see their signal, they're either gonna go into alarm or they're gonna go into trouble. One of the other new technologies that are coming out, it's through Australis, it's called an OSID. I don't know what they call them, what their acronym is for, but what it is one transmitter, and you can have up to 7 video receivers from one transmitter, and it constantly sends out to all of them. So that's new technology coming out. We got to get more information on before I bring it in and talk to the class about it. But that's where everything's going, and it's a video-based beam detector. It's basically the same, but it's not a live recording. It just uses. I'm not an expert on that yet. So, but in an area like this, if they really want detected, like I said, this is all sprinkled. Code requires nothing. Their insurance may want something in there. The owners may want something in there. These are options you can provide them. You can smoke the whole thing. You can put beam detectors, or you can put Vesta in there.
Are we what? No. Typically done by the mechanical engineer.
Yeah. When it comes to that, wherever they put their little dots is where I try to avoid. They get mad when I put a smoke detector in the same spot. They want to keep all theirs in a row. So. Typically we try to make it aesthetic as possible. So, but you know, we have to be at least 3 feet away from any diffuser or grill. We have to be at least a foot away from any light fixture. So when we're trying to install all our devices, we have to look at what's going on. So we try either going, you know, one way or going the other way. You should be able to have a clear path.
Any question guys about the manufacturing floor?
How many cubic foot grills you said?
3 feet. Grill or register. Yeah, they don't really make it easy on us when they plan these. When I design a system, it's based on final design will be based on the reflected ceiling plan with the mechanical. And I'll take and I'll overlay the mechanical, overlay the sprinkler, and then I'll do my design on it. So. Then you get into the fun of Revit, 3D building automation. We just done 3D modeling.
We're capable of doing it, yeah, you can look at it. We don't have collagen detection because we don't have other systems. But you can run collagen detection between here if you have a mechanical system.
Yeah, 3 of the last big projects I worked on, we had to do 3D modeling, show them where we're putting our support, and we had to have everything in there. It's quite interesting.
Stuff consuming.
Okay. Research lab. I'm going to talk about the research lab.
So research lab.
Second floor. sprinklers in there.
Smoke detectors removed.
Research lab, okay. Again, in the research lab area, you're looking at smoke detection every 30 feet on center. As far as I'm aware of, we don't have any air exchanges or anything going on in here. Is this whole area raised floor? Or just the lab?
The lab is not risky.
Just the base, these two bays here? The clean room base?
The clean room is just big containers of the room. With benches, these are benches supposed to be working bench.
So yeah, you have smoke detector every 30 feet, so 15 feet out, and then every 30 feet there. Now designing first smoke detector is going to be out. Here's your first smoke detector. Second one is 30. So on and so forth. That will give you your design layout for smoke detectors in a regular area. We have the .7 rules you can use, but I just like 30 feet. .7 rule mostly applies to elevator lobbies, and instead of going 30 feet on center, 900 square feet, you can increase it up to, I believe, 41 feet.
44, is that what we use the 20 foot radius?
41 feet. So you can go 41 feet between detectors in an elevator lobby area instead of the 30 foot spacing. And it's basically multiplying it. How did that go? I haven't used that in 8 years, so dire stretch. I know that it's there, but yeah, typically we design based off of 30 feet somewhere. I've seen it done. I've seen a book on it. In these bays, depending on what kind of machines and everything they're running in there, you're going to have smoke detectors dropped into the ceiling. I will send you a design. I just designed a system for a UTC in Burnsville that has a whole clean room system. And there are so many systems in here that interconnect into one. We have a nurse call 4-dome light that is in each bay on each side that they use for different colors. There's leaks, gas detection, leak detection. There's a manual emergency spill. The fire alarm system lights up a different color. And security or evacuation lights up another color. Because typically in there, they're not going to be able to hear because they're in full gowns. So you have to use visual indication while you're in there. They have typically LED scroll message boards to read any events that are going on. And they're not going to emergency evacuation, get out there if there's an evacuation spill. They'll have maybe a different sounding horn with a different color light flashing. Well, usually it's tied into the building automation, it's tied into the fire alarm system, it's tied into the emergency manual spill system, so it's all tied into all of those systems. So that if they, one of them were to hit, yeah, basically if one of them were to hit a button, scrolling message come out, and blinking light, so they either get out of there, or they know they have to stay in place because they have their own ventilation system. But if it's in each bay, and each bay has to act independently of the other one as well. So there's a lot of cross coordination and wiring that goes into this. Exactly. Because when you're in a clean situation, you're basically in a full hazmat suit. You can't hear anything. You have this main window that you're working on that you're looking like this. And you're not going to hear orange strobes. You got a lot of equipment around you. So what they need is they need that visual, something to catch their, so they look around and they can read the scroll board. It'll tell them, tornado coming, shelter in place, there's a fire, there's a manual spill, there's evacuation. And it should tell them everything about that.
So what's with, like, the 22 radius, I think that's like what, Houghton, when we did with Houghton, is what they do is they draw 22 radius, and that should cover, that's the area that's going to be covered by one smoke detector. I think it has to do with the, like you see, 30 by 30 in the center. And I think these sheets also, these circles that we have, I think they use the 22 radius circle for coverage.
Yeah, the NFPA space you got is 30 by 3900 square feet.
Yeah, I see.
So, and depending, instead of, you got 22 feet, okay, so there's one here. If this were to be 30 feet radius, you have nothing over here and one smoke detector over here. And that wouldn't cover it. It wouldn't cover the whole area. So what we do is we move this over. So this interlapping circles are going to cover every area. So, and typically, if 30 feet puts us right at the ceiling, we'll move it in 4 feet all the way up. Again, we had sounding in there. You're going to have interconference room, break room. You're going to have strobes. That's just a visual. In a conference room, we try not to put orange strobes in, just because of the small spacing. If you're looking at a voice system, you want to put a speaker strobe in them to get that audio notification in there. But with a orange strobe, or with a strobe in there, they'll be able to see it just fine. They'll be able to hear the orange strobe on here. Questions? Again, that's the class 1 div 1. You're going to have the smoke detector. You're going to have the class 1 div 1 strobe beacon, and then the class 1 div 1 horn. And that's all going to be a separate run-in. Any monitoring that has to happen in here, it goes through the intrusive safe. The monitor module is usually out here. It's going to be outside of the room, everything running inside. Usually you're going to put a isolation module after the monitor module to isolate any sparks or any surges that will be going through. But typically everything will be mounted outside. It's fully sprinkled in here. So again, they call out for putting in a smoke detector. It's a very expensive piece. The owners will typically come back and say, no, we don't want that in there. But again, the horn and the strobe are going to be intrinsically safe. Separate systems. You're going to have one beacon and one horn. And that should come here. questions?
We talked about the Siamese too. Siamese
No.
connection right here.
Yeah. Typically where the fire department's gonna come in, they're gonna hook up to the sprinkler system with their trucks. You're gonna see a horn strobe outside of the Siamese connection. Typically, this is a 120 volt system, or 120 volt horn strobe that's gonna be controlled and provided by the electrical and tied directly into the flow switch and tamper switch of the sprinkler contractor. Yep. And usually, again, 120 volts, so usually we don't touch it. They'll just run it straight through the where the horn strobe is located. It's gonna be located right above the Siamese connection, and they're gonna run that straight into where the riser is to the main flow. So all it does is just it goes off, tells the fire department, hey, here's where you need to connect. Any other questions, fire alarm wise? Or any that I've talked about? Okay. Jump right into technology. Assuming out in the manufacturing area, if I remember correctly, there's a cable tray system that's going in there. So typically to each, there's each different machine, you're gonna have computers running it, you're gonna have phone systems out there, so you're gonna run Cat5, Cat6 cabling.
Yeah, what we've done in the past, and that's for the cable triggers, is one system. Oops, am I going into nasty stuff here? So ran right above them, and then take them to. I think what we did is we took them to the right here to the telephone room, and then we tapped from here into the computer room, and also you can tap from right in here into we have they want them in the office. So what we typically did is ran one right to the top of the office, and then also grab this one right here. This is something similar to how we put the cable tray. One way. Everybody can see that. You need to capture the data from all these machines. So you put it right to the top of the machines and you capture them. Does that make sense? So that's one way. It doesn't have to look like this, but that's one way you capture the info from the office right here, from all these machines, take it to the telephone room as well as the data. So that's our data. And in the data, the reason why we stop here because you're underground, underfloor here, you can pick things, it goes down, you can pick things from underfloor.
Typically, they're gonna specify during the engineers are gonna put in the specifications whether they want 100 pair Cat6 run out here, or 50 pair, and tell you exactly where they want it ran. Because they have all that counted out already. For a design point, without sitting down and going through each and every one of these points and saying, okay, what needs connection to it, there's no way.
What we've done in the past though is, these are all options because you tie them at the end here, and maybe make more sense to tie them right in here. That's another way. As long as you capture them all, take them all the way to the phone line, as well as the computer room. Same cable tray that you got.
There are other ones depending on, you get really big, depends how many cables you're running down. Yeah. So it all depends on how many cables you're running, and typically the engineer will specify when you're working on a project. They'll tell you, yeah, 100 pair running down here.
As long as you're on it on the second floor too, so can we just jump up to the
You
second
see a lot of
floor.
100 pair fiber running here. Okay, well, good luck.
So on the second floor, there's
It's gonna be run
You're running off the ceiling, yeah.
And it all depends on the size of.
On the second floor, what we've
Size of
done,
the machines, because you're gonna wanna get above the machines, and where that's usually where they're going down, so.
what we've done in the past is we ran one of these to capture the hinge of these benches tied together, and they stop right here, and you go right through the wall. Right through the wall. That's one option of doing it, because then you have a power pole right here where you can drop down and pick up the data from these equipment. Again, if you look at the example that we have guys here, it went down, they had the cable tray all over. So, but that's the bare minimum. We had student design, they went with a cable tray right around the whole perimeter here. Like this, to capture from every end. I think it's gonna, these are benches, there's power pole coming from here, dropping down, bringing power, as well as low voltage to this bench. So, the bus with the power bus way, it could be like almost identical to the cable, almost identical to cable. When you do the bus with this, it's going to be almost identical to the out of the in the first floor of the cable, using different family. Any questions guys about the cable trays? I mean, the reason why we use this one, Matt, because we have a family for them. If you want to ask Matt about, the requirement for the cable tray and anything else, but in terms of design, this is one example. People have it there, we do have all the things family-wise for the cable trays, as in the process and ends and keys, all there. You should be able to build a really nice system. Some of them are labeled not. Yeah. Yeah, I mean, it's not field design. It's not the design.
Do we have to use cable trays on the second floor?
You were quite check. Now, do we have to enter the design? No, this is just what we're doing. You can do it, can't do it, but right now this is the specification.
For design and design with owner and sales. And then when you're doing the design, you're talking with the owner about what, you wanna design it so that it's common sense, so it's feasible, You wanna, when you're talking with the owner, you wanna give them the ultimate version. Because most of the time, 9 times out of 10, they're gonna come back and say, whoa, no, wait a minute. Then you go, okay, well, here, take this out this way, and you redesign it so that it's taking out something. Then they feel more comfortable doing that. But as long as you got it provided in each area where you think that someone's gonna be, then you got it covered. And you can explain that to the owner, say, hey, well, they go all about this person, but there's still this part right here, we can get there. I think the last thing,
Before we leave the data, guys, everybody understand that we have phone data. You're gonna have a phone data for all the offices. You're gonna have phone data in that area on the walls. In the lunchroom, at least one phone, one data. So when you use your imagination, you sit in the lunchroom, you have a phone data jack somewhere in the lunchroom. All the offices, all the clothes in all the offices. In the lab there, you need to be able, and what we asked for the lab later on, you will see it. We asked for a mold right in here, along the lab right in here, both sides. That mold, mold like this one. They run two sides, one low voltage, one high voltage. The high voltage have all exactly because you can plug in as you work, and the low voltage would have one in there. So that's where the lab. Yeah, on each side, as a matter of fact, we have a mold right now that goes in this side, and another one that goes in the other side. But that's for the there is one we do this one in the power. When we do the power, leave this one into the power. When we do the power without the battery, we heat on it as low voltage and low power. In the power, not low voltage. Yeah, but if I were you, like this is a lab area, you probably wouldn't care to have a couple of phone data on at least one in the center of every wall. Yeah, phone data right on the walls and in the center of every wall. Wouldn't care, especially when I'm not paying for them. Sorry. Okay, so the security index.
Yeah. First board. With security systems, like code or like fire alarm, there's no code requiring what you have to have. So when it comes to fire alarm system, your design is going to base heavily on what the owner wants. Or, you know, with a lot of them, they'll go, okay, we'll just design us a fire or design us a security system. Well, you start off with, like I said, the max. You build a complete system, you give them that price, and then you say, okay, we're going to scale back because they're always going to come back and go, whoa, whoa, whoa. Once they see the pricing of it. Typical fire alarm or burn system, security system. We're not talking cameras in this facility, but we are talking keypad entrance. So main security panel. Yeah, in a building like this, you're going to have right in front door here. You're going to have a keypad that's going to go into the main security panel, which I assume probably will be like a telephone room. Yep. And that's going to be dialing out to the central station. The keypad, whether they have a card reader on it or just have it as a straight keypad, you know, ADT type deal. They usually have one at the front and one at the rear by the parking areas, so that people, when they come in, if they have a key, they can arm and disarm as they go out, or when they come in, depending on the maintenance. You can put one at every exit, but that's kind of defeats the purpose of it, because they usually, what they try to do is limit who can arm and disarm the system. Yep. Yeah. If you're going to put a card reader system, then you can put it at every door, because they can go into any door and they can use their cards, swipe them at the door, and be able to get in. And again, that's tied in with a relay through the door contacts on each door. And usually you're going to have, on the other side, you're going to have a request to exit on each door as they're coming out, so it's going to unlatch that door. Typically, in a building like this, it all depends on what the owner wants. If they just want a keypad to arm and disarm at night, one on each side. That's another option. You know, you design it full of card readers. They say, well, we don't want that. Okay, well, here's 2 keypads. You're done. The glass break detectors are going to go along the outside.
That's why I had this section just to show you guys, if you look at this section, here's where the windows are located, believe it or not. If can see the second floor in the manufacturing area, only the second floor, so we still need glass break because we don't want the thugs to run to the second floor and jump in. It would be impossible, but
Yeah, you can,
you
like,
can see where the windows are located.
these areas down here, these windows down here are gonna be your main concern. There's a roof hatch that you're gonna have a door contact on. If I remember correctly.
Yeah.
Outside on each door, you can have door contacts on each door. It depends what the owner wants. I mean, if there's access to that area, to those windows, then yeah, they probably should have it. If you can easily get to those windows, like you can't climb up in this window. There's no sense in having a glass break here. But on the perimeter, on the outside, on the first floor, you might want to put them there. If there's, over here, or there's a window, say over here, and there's a dumpster over there that leads right up to that window, yeah, you might want to put one in there. It depends, again, what the owner says.
There's some windows in the back of the, that you guys can see, there's some windows in the first floor.
Usually it's just a pair, twisted pair of wire that's gonna go right through it. No, and it's just, and it can, you tap right out to the next one. They're addressable points on the system. They do make wireless glass breaks and wireless security systems. That might be an option to look at. Again, it all depends on what the owner wants. If this were my building, I would want, security cameras around, mainly in the parking lot areas, watching the front door. Where's the heavy traffic? You're going to have motion detectors going throughout the main corridors, the entrances. You have motion detectors in the dock area, in the main office. You can have motion detectors. You can have those tied into the lights, so that if somebody does arm it, that motion detector turns the lights on. If it's before the hours when the lights automatically turn on the timer. There are a lot of different options you can do, and again, I can't stress enough, it's what the owner wants.
Well, I'm thinking, well, here's what the owner wants first. That's what the owner wants. And that's your preference, right? That's what we give you. Now, if you would go for smart meters and cameras and all this stuff, be my guest, but be aware you have to find a pen for that. Everything go a low voltage, you have to find, it's not a big deal, you have to have the cameras for it. You really understand what we need, what the owner wants, and what you said is that the best design is probably putting cameras. If you go that far, great, but be aware that you have to do some research for the cameras. Right.
So yeah, looking at this, you got door contacts and all exterior doors. Those are just magnetic contact with the door breaks, releases that magnet, and goes into alarm. I got the motion detectors in the corridors, glass break sensors in rooms with exterior perimeter windows. An audible alarm is usually just internal to the panel. It's going to go off and just sit there and wail. I'm sure you've all heard those before. It's like a car alarm. Hit it, just keeps going off until someone's jumping down. The audible alarm is usually going to be right at the front annunciator keypad area, or wherever you have the main panel. And it's going to sit there and just wail like a siren. There are some buildings that they'll put a little sounder outside, right above the signage connection. You got the main door. All of a sudden it just start going on siren. Someone's breaking in. If there are neighbors around or a cop driving by, somebody's going to notice that and stop over. In the meantime, the system is going to be calling through the dialer to the central station, who's going to call the head maintenance guy, who's going to come down and say, okay, let's take a look at it. So we got our door contacts on all the exterior doors. call out for, but they have roof hatches. There's gonna be door contacts on those. Because you get up there. But you also got, if someone gets up there, you have motion detectors in the hallways, in the office areas, in the loading dock area. So if someone forgets to close the gate all the way, they come in, motion detectors going off, they're gonna get a call. Any other questions on security? Anything to talk about? Any questions on the industry?
If I might say one thing, guys, Matt wasn't, you told us that you were in this class, so the low voltage is a specialty by itself. You can make money specializing just in firewall security point of view. So the field is so deep, like you said, there's so many regulations, so many code requirements that it will be impossible for one person to be able to size a generator and a switch gear and at the same time be expert in switch gear and generator and then at the same time expert in file line security and phone and data. So people specialize at one time. The reason why we bring Matt and everybody else in low voltage to let you know that there is a field that's called low voltage and you can make a lot of money doing design and or installation. That's going to be a win there. And the state of Minnesota, Eaton has a whole combination of low voltage filters. Every company, every electrical company almost now we have a section specialized in low voltage. Even Michelle Fuller Erickson, we have the, I believe
Yeah, they have low voltage.
low voltage design group that all what they do is firewall security reporting data. So they become expert, they become expert in the code related to all these aspects. So again, at one time when you leave us here, you have to specialize. You can't be, it's impossible to know all the stuff that we report. It's too much. You become an expert in all.
It's good to know a little of everything, but
At one time, you were specialized in certain areas.
it's wide out there, whatever. You ever passionate about anything, it's out there, you can do it.
Did you tell them about how you got your job with okay, cool.
Yeah, so Bob came in, my boss, president of our company, came in and talked to our class, and